All right, let's go. Number 10, gamma ray burst sources. In the 1960s, the United States military satellites designed to detect nuclear explosions on Earth began picking up mysterious bursts of gamma radiation arriving from deep space. What these satellites had accidentally discovered represents the most violent and energetic explosions in the universe since the Big Bang itself. These events, now known as gamma ray bursts, or GRBS, are the absolute apex of cosmic violence. A typical GRB releases more energy in a few fleeting seconds than our sun will produce over its entire 10 billion year lifespan. The source of this extraordinary power was finally confirmed in the 1990s. GRBS mark the violent birth of black holes. They occur when a remarkably massive star undergoes a catastrophic core collapse at the end of its life, or when two hyperdense neutron stars collide and merge in a terminal orbital dance. The energy released by these events is so extreme that for a brief moment, the burst outshines the rest of the visible universe combined. What makes gamma ray bursts particularly terrifying is their sterilizing power and absolute unpredictability. The intense gamma radiation from a burst aimed at Earth from within 3,000 light-years would completely destroy our ozone layer, instantly exposing the planet's surface to lethal levels of ultraviolet radiation from the sun. Some paleontologists have even proposed that the Ordovician extinction event, which wiped out 85% of all marine species 440 million years ago, may have been directly caused by a distant GRB striking our planet. If a GRB occurred in our galaxy and happened to be pointed directly at Earth, it would be visible in broad daylight, appearing as a brilliant, searing flash in the sky before total ecological darkness fell across the planet. In 2022, astronomers detected GRB 2210009, nicknamed the Boat, brightest of all time, which originated 2.4 billion light-years away, yet was still powerful enough to measurably disrupt Earth's ionosphere. Had this burst occurred within the borders of the Milky Way, it would have caused a global catastrophe. These phenomena serve as cosmic snipers, capable of eliminating life across vast interstellar distances with absolutely no warning. Their existence raises a deeply troubling possibility regarding our search for extraterrestrial life. Perhaps the universe periodically sterilizes otherwise habitable worlds through these random, blinding bursts of gamma radiation, constantly resetting the clock on biological evolution across entire galactic neighborhoods before advanced civilizations ever have the chance to leave their home worlds. Number 9. Neutron stars. When a massive star reaches the end of its thermonuclear life, it doesn't simply fade away. If it isn't quite massive enough to form a black hole, its core collapses inward with incomprehensible force, crushing protons and electrons together until they fuse into a singular, solid mass of neutrons. The result is a neutron star. These stellar remnants are already one of the densest objects in the universe, featuring a mass greater than our sun, compressed into a sphere only 20 kilometers across. To put this density into perspective, a single teaspoon of neutron star material brought to Earth would weigh roughly 10 million tons, equivalent to the weight of a massive mountain. But the sheer density is only the beginning of the horror. The gravitational pull on the surface of a neutron star is billions of times stronger than Earth's gravity. If you were to drop an object from just a few feet above a neutron star, it would accelerate to millions of miles per hour before striking the surface, releasing explosive energy upon impact. What makes neutron stars truly terrifying, however, is a specific subclass of them known as magnetars. These variants possess magnetic fields that are the strongest in the known universe, approximately 1 quadrillion times more powerful than Earth's magnetic field. A magnetar's magnetic field is so intense that it could erase every credit card on Earth from a distance halfway across the galaxy. If a magnetar were to appear within 1,000 kilometers of our planet, its magnetic force would physically tear your body apart atom by atom. The electrons in your atoms would be violently wrenched away from their nuclei, causing instantaneous tissue dissolution. These objects are also notoriously unstable. Their powerful magnetic fields create immense internal strain, causing the star's solid, hyperdense crust to fracture periodically in what astrophysicists call starquakes. These fractures produce random, unpredictable eruptions of gamma rays and X-rays that can sterilize surrounding space. On December 27, 2004, scientists recorded the effects of a magnetar eruption located 50,000 light-years away. It released a burst of energy that briefly outshone the full moon and measurably affected Earth's upper atmosphere, releasing more energy in a tenth of a second than our sun produces in 100,000 years. Had this occurred just 10 light-years from Earth, it would have triggered a mass extinction event. Number 8. White dwarfs. In the cosmos, stars are expected to follow certain immutable laws of physics. When stars like our sun run out of hydrogen to fuse, they swell into red giants, shedding their outer layers before collapsing into small, incredibly hot and dense cores known as white dwarfs. A white dwarf is essentially a cosmic corpse, a glowing ember of carbon and oxygen roughly the size of Earth, but containing half the mass of the sun. This is the inevitable, inescapable fate of our own solar system. But the horror of white dwarfs lies in their parasitic nature and their uncanny ability to cheat death. When a white dwarf exists in a binary system with a living star, its intense gravity allows it to siphon plasma off its companion. The dead star actively feeds on the living one, pulling a continuous stream of hydrogen onto its own surface. As this stolen material accumulates, the pressure and temperature reach critical mass, triggering a runaway thermonuclear explosion. Sometimes, this process creates what astronomers call zombie stars, white dwarfs that undergo a partial supernova but miraculously survive their own destruction. Officially known as Type 1 AX supernova remnants, these partial explosions somehow leave behind a surviving stellar core, which was previously thought to be a cosmic impossibility. The star undergoes an explosion, powerful enough to outshine entire galaxies. Yet a portion of it stubbornly remains intact, transformed and scarred, continuing to shine as if defying death itself. Astronomers now believe up to 30% of what we classified as Type 1, a supernovae, may actually be these partial explosions with surviving undead stars. The implications of white dwarfs are profoundly unsettling. We are observing planetary executions playing out over millions of years. When our own sun eventually becomes a white dwarf, it will first expand to consume Mercury, Venus, and likely Earth, boiling away our oceans and stripping our atmosphere. After the destruction is complete, our sun will spend billions of years as a cold, dense, fading white dwarf, slowly cooling into a theoretical black dwarf until the end of time. It is a slow, inexorable death, a reminder that the universe has no mercy for the worlds it creates. Number 7. Pulsars. In 1992, astronomer Alexander Woljan made a discovery that completely defied conventional understanding of planetary formation and survival. He found 3 planets orbiting a pulsar 2,300 light-years from Earth. They weren't orbiting a normal star, but the ultra-dense remnant of an exploded star, a cosmic corpse spinning at 161 rotations per second and blasting its surroundings with lethal radiation. These were the first exoplanets ever discovered outside our solar system, and they orbited in the absolute last place anyone expected to find worlds at all. Pulsars are a highly magnetized, rapidly rotating variation of neutron stars. As they spin, they emit powerful beams of electromagnetic radiation out of their magnetic poles. Because their magnetic axis is misaligned with their rotational axis, these beams sweep across space like a cosmic lighthouse. If Earth happens to lie in the path of this sweeping beam, we detect regular, clockwork pulses of radiation, sometimes occurring hundreds of times a single second. The environment surrounding a pulsar should be utterly sterile, completely scoured clean by the supernova explosion that originally created it. Yet somehow, the planets orbiting PSRB 1257 plus 12 exist in nearly perfect circular paths. Scientists propose 2 terrifying possibilities. Either these planets survived the original supernova, enduring temperatures of billions of degrees and radiation that would vaporize most matter, or they formed afterward, coalescing from the irradiated debris ejected during the stellar explosion. Born from the ashes of their star's violent death, these worlds have been dubbed zombie planets. Dead worlds orbiting a dead star in a system bathed in energy levels thousands of times stronger than anything in our solar system. The rotation of a pulsar is a testament to extreme physical forces. Imagine an object with the mass of the sun, condensed to the size of Manhattan, spinning so fast its equator moves at a significant fraction of the speed of light. The centrifugal forces at play are staggering, yet the immense gravity of the dead star holds it all together. Standing on a world orbiting a pulsar would mean enduring skies dominated by an impossibly fast, blindingly bright strobe light of lethal X-rays. They prove that worlds can exist in circumstances we once thought absolutely impossible, locked in the most hostile environments imaginable. Number 6. Stellar black holes. In the vast darkness between the stars lurk cosmic nomads with the power to tear apart absolutely anything that crosses their path. When a massive star runs out of nuclear fuel, gravity wins the ultimate battle. The core collapses inward infinitely, piercing a hole in the fabric of space-time and creating a singularity, a point of infinite density. The gravitational pull becomes so intense that past a certain boundary, known as the event horizon, not even light can achieve the escape velocity required to break free. While the concept of a black hole is terrifying on its own, what makes them the subject of pure cosmic dread is that many of them are not stationary. Stellar corpses can be violently ejected from their home galaxies during asymmetrical supernova explosions, giving them a natal kick that exceeds the gravitational binding force of their host galaxy. These are rogue black holes, wandering the cosmos with no fixed destination. Unlike their supermassive cousins anchored at galactic centers, these gravitational monsters travel at astonishing speeds, some exceeding 1.5 million kilometers per hour. Once ejected, a rogue black hole becomes a silent, undetectable predator. Because they emit absolutely no light, they are near perfectly invisible. We can only detect them when they actively consume matter, or through rare gravitational microlensing events, where their gravity briefly bends and magnifies the light of a star passing behind them. Astronomers estimate that up to 100 million rogue black holes may be silently drifting through our Milky Way galaxy alone. Their trajectories are essentially unpredictable, making them cosmic wildcards capable of completely disrupting any stellar system they approach. If a rogue black hole were to enter our solar system, it wouldn't even need to hit Earth directly to cause total catastrophe. Merely passing through the outer solar system could permanently destabilize planetary orbits, sending comets and asteroids hurtling toward the inner planets, or flinging Earth out of the habitable zone entirely into the freezing void of deep space. We would have virtually no warning if one was approaching until it began to gravitationally pull our planetary orbits apart. Number 5. Supermassive black holes. If stellar black holes are the wandering predators of the universe, supermassive black holes are the immovable leviathans holding entire galaxies hostage. Sitting at the very center of almost every large galaxy, including our own Milky Way, these entities possess masses, millions, or even billions of times greater than our Sun. For decades, they were thought to be relatively quiet, only periodically feeding on gas and dust. But when they actively consume matter, they power the most brilliant and destructive phenomena in the cosmos, quasars. In 1963, astronomer Martin Schmidt discovered what appeared to be a faint blue star, but was actually an object so luminous it outshone its entire host galaxy, despite being confined to a region smaller than our solar system. Quasars are powered by supermassive black holes actively devouring surrounding matter at rates that defy human imagination. As material spirals into the black hole, it forms an accretion disk that is heated to millions of degrees through intense friction, releasing energy across the entire electromagnetic spectrum. A typical quasar produces more energy than 100 trillion suns, acting as a cosmic furnace of almost unimaginable intensity. What makes them particularly terrifying are the relativistic jets they produce, focused beams of radiation and particles accelerated to near light speed that can extend across millions of light years. These jets contain enough sheer energy to completely sterilize any galaxy unfortunate enough to lie in their path. The quasar PKS 0637-752 produces a jet extending over 1.5 million light-years, which is 5 times longer than the entire Milky Way galaxy. Even our own galaxy harbors a violent past. In 2010, astrophysicists discovered the Fermi bubbles, Two enormous structures of high-energy gamma radiation erupting from the center of the Milky Way, extending roughly 25,000 light-years above and below the galactic plane. These structures contain energy equivalent to hundreds of thousands of supernovae, triggered by our central supermassive black hole, Sagittarius A star, undergoing a period of intense feeding several million years ago. Supermassive black holes remind us that galaxies are not just peaceful collections of stars. They are violent whirlpools swirling around a central drain capable of awakening and sterilizing thousands of light years of space in an instant. Number 4. Hypervelocity stars. Most stars in the Milky Way, including our Sun, follow relatively calm, predictable, circular orbits around the galactic center. They move at speeds dictated by the collective gravitational mass of the galaxy. But out in the dark, there are rogue wrecking balls blazing through the interstellar medium at speeds that defy local gravitational constraints. These are hypervelocity stars, massive, burning spheres of plasma moving so fast they are completely untethered from the galaxy, destined to escape into the immense, empty void of intergalactic space. The horror of hypervelocity stars lies in their origin and their velocity. To achieve speeds exceeding 1 to 2 million miles per hour, an object with the mass of a star requires an unfathomable kinetic kick. Astronomers believe these stars are created when a binary star system, two stars orbiting each other, strays too close to the supermassive black hole at the center of the galaxy. The extreme tidal forces of the black hole capture one of the stars, ripping it away and consuming it. The laws of orbital dynamics and conservation of momentum require that the energy from this violent separation be transferred to the surviving star. The remaining star is slingshotted outward with such violent force that it achieves galactic escape velocity. Imagine a star, vastly larger and hotter than our Sun, moving as an unpredictable, rogue projectile through the galaxy. If a hypervelocity star were to pass through a populated region of the galaxy, the gravitational devastation would be catastrophic. Unlike a rogue black hole, a hypervelocity star announces its presence with intense heat, blinding light, and massive stellar winds. If one were to tear through our local stellar neighborhood, its gravity would completely scramble the Oort cloud, sending a civilization-ending barrage of millions of comets raining down into the inner solar system. It forces us to confront a terrifying reality about the architecture of our universe. The cosmos is not a static, peaceful diorama. It is an active shooting gallery where massive, burning objects are constantly being fired into the dark. These stars will spend eternity flying through the freezing emptiness between galaxies, completely alone, illuminating nothing but the void. Number 3. Cosmic string candidates. Moving away from the physical objects we can see and measure, we enter the realm of topological defects in the very fabric of reality itself. Formulated within the framework of string theory and early universe cosmology, cosmic strings are hypothetical, one-dimensional fractures in space-time. When water freezes into ice, cracks and imperfections naturally form where different crystalline structures meet. Theoretical physicists believe that in the fraction of a second after the Big Bang, as the universe rapidly expanded and underwent fundamental phase transitions, similar cracks formed in the vacuum of space. These are not the microscopic, vibrating strings of quantum string theory. Cosmic strings are macroscopic objects, potentially stretching across the entire observable universe. Because they are one-dimensional, they have no width or depth. They are infinitely thin. Yet, their density is mathematically incomprehensible. A single inch of a cosmic string could weigh more than the entire Earth. If a cosmic string exists, it is slicing through the vacuum of space at a significant fraction of the speed of light, whipping and thrashing under its own immense tension. The terror of a cosmic string lies in its interaction with normal matter. Because it is infinitely thin, if a cosmic string were to pass through you, it wouldn't crush you like a blunt instrument. It would slice through you at the subatomic level. If one were to pass directly through our solar system, it would slice through planets, moons, and the sun like a cosmic scalpel. Worse still is the gravitational wake it leaves behind. The intense gravity of a cosmic string passing through Earth would warp space-time so severely that it would trigger global tectonic collapse, instant hypervolcanism, and tidal forces capable of tearing the crust into liquid ribbons. While they remain hypothetical, Astronomers have searched for evidence of them by looking for specific, linear gravitational lensing patterns in the cosmic microwave background. The idea that a fundamental, infinitely sharp error in the universe's code could simply whip through our region of space, severing the physical bonds of our planet without warning, makes cosmic strings one of the most unsettling theoretical objects in astrophysics. Number 2. Primordial black hole candidates. When we think of black holes, we think of the collapsed remnants of massive stars. But standard physics dictates that a star must have a certain minimum mass to collapse into a black hole. Otherwise, it stops at a white dwarf or a neutron star. However, in the very first second after the Big Bang, the universe was in a state of hyperdense, superheated plasma. The pressure and density of the universe were so extreme that microscopic fluctuations could have caused local regions to collapse into black holes long before the first stars even existed. These are primordial black holes. Unlike stellar black holes, primordial black holes are not bound by the mass limits of dying stars. They could theoretically be of any size. Some could have the mass of 100,000 suns, others could be the size of an apple, but pack the gravitational mass of planet Earth. The most terrifying candidates are the microscopic ones. A primordial black hole could be the size of a single proton, invisible to any instrument we have ever built, yet weigh as much as Mount Everest. Because they formed in the early universe, billions of these invisible anomalies could be scattered throughout our galaxy, behaving like dark matter. What makes them deeply unsettling is the sheer probability of intersection. If a stellar black hole approaches the solar system, we might eventually notice the gravitational disruption to distant stars. But a primordial black hole the size of a golf ball could be hurtling through our solar system right now, completely undetectable. If a microscopic primordial black hole collided with Earth, it wouldn't swallow the planet whole like a traditional black hole. Instead, it would puncture the Earth like a high-speed bullet. It would enter the crust, pass straight through the molten core, and exit the other side of the planet, leaving a microscopic, superheated tunnel of destroyed matter in its wake. If one were slightly larger, it could become trapped in Earth's gravitational well, sinking to the core where it would slowly, inexorably begin to devour the planet from the inside out over millions of years. We are completely blind to them, sharing our galaxy with relics of the Big Bang that possess the power to drill through planetary bodies with total impunity. Number 1. Phoenix Cluster Black Hole. There comes a point where the scale of cosmic objects surpasses our capacity for rational comprehension. Supermassive black holes, like the one at the center of our Milky Way, are already difficult to grasp at 4 million times the mass of our Sun. But deep in the constellation Phoenix, located 5.7 billion light-years from Earth, sits the Phoenix Cluster, one of the most massive galaxy clusters in the universe. And at the absolute center of this cluster lies an apex predator so unimaginably colossal that astronomers had to invent a new classification for it: the ultramassive black hole. The black hole at the center of the Phoenix Cluster has an estimated mass of 100 billion times that of our Sun. To understand the sheer horror of this scale, consider the event horizon, the boundary beyond which nothing can escape. The event horizon of the Phoenix Cluster black hole is approximately 590 billion kilometers in diameter. If you were to place this black hole in the center of our solar system, it wouldn't just swallow the Sun. It wouldn't just swallow Earth, or Jupiter, or Neptune. Its event horizon would extend more than 100 times further out than the orbit of Pluto. It would completely obliterate the Kuiper Belt and swallow the inner Oort cloud. Our entire solar system, everything humanity has ever known, observed, or sent probes to, would easily fit inside the pitch-black void of this single object, with billions of miles to spare. Unlike many supermassive black holes that lie dormant, the Phoenix Cluster black hole is intensely active. It consumes massive amounts of matter, but paradoxically, this violent activity is driving the most furious burst of star formation ever observed in a central cluster galaxy. It is growing at a rate of 60 solar masses every single year. The terror of the Phoenix Cluster black hole is existential. It represents the absolute ceiling of physical reality. It is an object so dense, so massive, and so gravitationally dominant that it warps not just space, but our fundamental understanding of how the universe structures itself. It stands as a monument to the staggering, uncaring scale of the cosmos, a reminder that our planet, our sun, and our entire solar system are nothing more than microscopic dust motes in a universe dominated by titans of absolute darkness. If you want to see more videos like this, click the video on screen now and make sure to subscribe.